All right. All right. All right. All right. All right. All right. I'm gonna test this out to see how it works. Okay, so today I'm gonna do some lead code. Just practicing to build those skills. As you guys know. All right. So let me see what is the problem for today. Let's go. All right, let me change the screen. All right. I'm I'm gonna start. I'm gonna pause this. Hopefully, it's not too loud. I think that should be perfect. So, let's see something real quick. Let's see something real quick. Oh, I thought we were the mic was on. It wasn't. All right. So okay. So I was saying that I haven't solved. Today I'm gonna try to see if I could solve the greatest common divisor of string, and then maybe solve another one like increased triplet consequence or product of various except. It says that I solved this before somewhere else, but I don't know where other places that I solved it. Doesn't make sense, but yeah. Let's see. Oh, okay, that makes sense. Let's actually delete that because I don't remember nothing. Nothing. So we're gonna probably just do that from here. Okay. This one I think I started solving it like 2 days ago, but I couldn't figure out what was wrong with it. Let me try to see if I could get a board, like a yeah, one of those whiteboard. All right, so okay, perfect. Hopefully this is not, this is okay, that's perfect. All right, so let's just read the problem, because the problem, to solve it, we have to actually read it and understand what's going on here. So we have the greatest common divisors of string. I'm assuming that we have two strings, yeah, right here. All right, so for two string S and T, we have, if I say this one, we have S, and then we also have T. Let's put it that way. So we have two string. We say T divide S. We say T divides S if and only if S equals T, 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 etc. Which means T is concatenated with itself one or more time. Okay, so T maybe, I'm gonna take those examples that's there. So it says T is concatenated. Okay, perfect. So one or more time. So T might be ABC, ABC. Okay, let me see if there's like another example that I can take you on. So let me see. All right, so we're gonna put S equals, let's grab this one because I think that one is like more expensive. And then we have also have T, which is gonna be right here. So S is AB, AB, no, oh, okay. If and only if T is T, T, okay, what? So this is ABC, so ABC, ABC, so this is twice. We should return what? Return the largest string of X, such that X divide both string 1 and string 2. So it has to be like a even number when you divide it, I guess. Okay, so we have ABC, ABC. So ABC divided by ABC again is gonna equals, that's gonna equals 2, that's gonna equals 1. So for this one is AB, AB. If we divide AB, AB, that's 1. Also, the string is actually AB itself. Oh, that makes sense. So we're gonna take AB. So AB, 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 that's gonna be equal to 3. And then we have this one that equals 2. So when you put it together, it's gonna equals 2 or 3. Okay. So whenever you divide the string, it gives you those two things. String 1 and string 2. Let's say this one is leet and then code. That's gonna output nothing. It's perfect. I don't need to try this on. So far that makes sense, right? So far that makes sense. All right, so let's keep going. So we're given those two strings, S1, S2, R1, S2, R2. All right, so what we're gonna do, maybe if we check if STR1 STR1 not, wait, not equals to STR, no, actually if we sum those two, they should equal the same whenever you sum it. For example, if we say ABC, ABC plus ABC, these gonna equal the same. But if you sum these two, they're not gonna equal the same. All right, so if str1 plus str2 not, we can say not equals to str2. Wait, I should have put str2 here. So str2 plus str1, I guess we should just return nothing. So sd return, I'll say an empty string. Yeah, just like that. That means if we run this, this would pass the third perfect. It passes the third test cases. It's not gonna pass those because it's gonna return nothing. But this is already returning the actual empty string. So that's good. So now let's go with the other cases. Now let's say we're gonna let's say we're gonna let me see. We're gonna create a for loop. Nah, because if we loop through this and this together, that's kind of interesting. Okay, so if we solve this problem, now I'm trying to think of like the perfect way that I can solve this problem. Let's say we're gonna if we loop through this, or actually we could actually put a pointer. If we point here and point here is the same, we check on the next one. We point here, the same. The problem is that we're gonna loop and then this is not gonna equal the same. I really get stuck in this problem. This is a math algorithm. The person is gonna check if the boolean is valid. What? Let me go with Python because I'm not gonna do that. It create. Oh wow. For I in the range of minimum the length of 1, 0, -1. This kind of doesn't make sense, but let's see. Let's see. All right, so So the algorithm is to find the shorter string among str1 and str1 without loss of generality. Let it be string 1. So if we start with base, which is going to be string 1, check if both str1 and str2 are made of multiple of the base. If so, return the base. Otherwise, we shall try another string by removing the last character from the base. If we have checked all the string without finding the GCD string, return nothing. That's a high level complicated stuff right there. I don't even understand what the hell is going on. But let's keep going. Those are like other like way of solving it, I think. Let me see, what was this? Oh, perfect. Is there a GCD? The grand divisor GCD in Python. Oh, what's going on? GCD. Oh shoot. That's perfect then. So if there's a Python function that it really can calculate the GCD for us, we can technically just use that. But do we have to import anything? I don't know. Let's see. So 24 divided by 6 is 5. But 54 divided by 6, wait. I'm kind of slow on math right now. 54 divided by 6, that's 9. That's 4. 4 times 6, 24. Why is this GCD? Oh yeah, that's right. 6 and 9 is divisible. This is divisible by 6. Because if we put 54, wait, 54 divided by 6 is equal to 9. I guess that was the common divisor. This is the common divisor. This one, I don't know. Perfect. So I guess we can use that, but I'm a little confused on why it calculated the mask length by the GCD of the length of string 1 and the length of string 2. Oh, that's perfect. So if this is 1, 2, 3, 4, 5, 6, but this is 4, the common divisors of both 2 is 2. But this one, ABC, A 1, 2, 3, 4, 5, 6, but this is 3. The common divisors is 3. So the longest string is gonna be 3. That's so good. Okay, so let's not continue looking at this and going back to our thing. So what we're gonna do? Oh shoot! What we're gonna do? We're gonna say the max length actually max length. Wait, max len, perfect, equals, we're gonna say GCD. Oh, we have to calculate the GCD. Did he create a function? There is a function that says GCD. So let's keep going. We're gonna find the GCD by using the length of string str1 and then the length of the str2, and then after finding the GCD we're gonna say let me print max length to see, wait, max length to see what it gives us, because I wanna see and understand what the hell I'm doing. Okay, this is gonna be 3 because yeah, that's perfect. Because this is what's supposed to be. Oh, that's perfect then. This is 2. Yep, exactly what I would have predicted it. So what you can do, what we can do is use that number to return str1 as seen, like up until max length, because string 1 is always longer than string 2, right? T is always part of the S, which is gonna be string 2 is always part of str1. So let's run this to see how it does. That's perfect. I looked at the solution kind of, but we understand how it checks if you add these two together is gonna give you, wait, these two together is gonna give you the same if you add this one in the front. It's the same thing. So what I did here is that I add them those two, and I added the inverse of this two. If it's not equal, we return nothing. And then what we did, we calculated the max length of the part of the string that we are looking for. We calculated the grand divisors, like that means how much you can divide these two by these two. Yeah, sorry. It can divide these two by these two. Like what? If it find the the divisors, the common divisors of these two strings, and then it returned it. After I return it, I return the part of the string that I need. So whenever we submit, let's see how the thing does. Perfect. Damn, beat 100%. It's crazy. That's pretty high, but I don't know how, but yeah, it passed all the test cases. This is the solution that we just wrote. All right. So let me see how the other solutions was laid out, because this was the solution that I just implemented. Let me see if I can understand a little bit of this. It calculated the length of string, and then it have a whole function. If the length of if the length of wait, oh perfect. If the modulo of that one, oh, this is checking if it's valid. So for every value in the range of the minimum len 1 or len 2, starting from 0 until -1. Wait, what the hell? Can I kind of understand this line? We're gonna use ChatGPT real quick. ChatGPT that. So explain this line. So this is a for loop. The minimum between these two is 3. So 3, 2, 1. Now let me this for loop is a lower sequence number of the range starting from the minimum of the length of string those two and counting down to 1 because it stopped before reaching 0 and stepping -1 in each integration. So you find smaller the length of string 1 and string 2, you start, stop, and step. -1. Oh, that's perfect. That's why I was like, wait, what? I forgot about this in Python. Okay, so that's perfect. Let me see. Wait, what? Okay, that's where I was. So this is gonna check if this is it ends before 0. Is step h1. If I is valid, that means if it's 2. Okay, let's say the shortest range of this one, let's say is 3, right? These 3. The shortest thing is 3. We're gonna try 3. Well, actually, we're gonna try 4 here. And then if the value 4 is valid, you're gonna return that. If it's not, you're gonna iterate again to the for loop. So it's gonna start with the wait 1, 2, 3, 4. So it's gonna start with 4. 4, is it valid? So it's gonna go to 4. If the length of 1, which is gonna be string 1, modulo k, which is the 4, modulo 4, or length 2, modulo 4, this is gonna equal 0. The modulo 4 is gonna be equal 0. And then it's gonna return false. So this is gonna equal 0. Okay, so he has to do one of them, either or. So n1, n2 equals to n length of this, the base. I cannot understand this. String 1 equals n1 times the base, and string 2 equals n2 times the base. Interesting. Alright, so this problem, I definitely need to start this problem and go back to it because this problem is very, 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 very interesting. And it's like we have 10, baby. So it's like it's like a hassle. So the problem number 2, we have to come back to it to really go deep into it to try to solve it. Perfect. So we're gonna close this problem out. Let's try this problem. This is a medium problem. Let's see how long it's gonna take us to do it. I have about 20 minutes to kind of go over this problem. Product of array except self. There was a comment here. We're not gonna focus on that comment. Given the uninteger array num. So is this num is gonna be array full of integers. Return an array answer such that our answer at I is equal to the product of the element of num except nums at I. The product of any prefix or suffix of num is guaranteed to be a 32-bit integer. You must write an algorithm that runs in O of n time without using the division operation, which is gonna be the product of array set self. You're given the array num, we have these full of integer, return an array answer. We're gonna have an output which is gonna be this, such that answer at I, so answer at I, answer which is number 24, is equal to the product of all the elements of nums except nums at I. So 2 times 3, 6 times 4 equals 24. So every number here is going to equal to the product of everything except the actual product. So that's why they don't want us to use that division operation, because we could just literally calculate everything and divide it by this. Because if you calculate everything and divide it by this one, it's going to equal 24. You divide it by this one, it equals 12, because it's 1 times 3 is 3, 3 times 4. Wait, 4 times 12, yeah. 3 times 4, that's 12. And then if you go right here, number 3, if you divide everything, so 2 times 4 times 1, 2 times 4, 8. No, wait, what? 24 is the total of everything. Divided by 3, that's gonna equals 8. So that's why they don't want us to write without using the division operation. Okay, so how do we solve this problem? I do not know yet. Let's see how we can implement that. So every number here is gonna be a product of every other number. Yes, the O and M and algorithm. What did this note was? I noted that before. Array of num, return an array answer. Answer at I is the product of a number. You look through the array of numbers, multiply the values before, then append to the array, multiply the first append to the array, multiply the previous value. Alright, so we're gonna return an output which is gonna be answer equals, I don't know what I'm doing, but equals an empty array, right? And then what we're gonna do is that to solve this problem, let's actually whiteboard this. So let's grab this. So this value 1, we're gonna loop through this. We take this one. Or what if we start at the end of the array? No, that's not gonna be anything. So if we start here, number 1, we append it to the array solution, which is gonna be 1. No, we cannot append it. Because if we append it, it's gonna be bad. So let's say we're gonna loop through this to calculate the total value of everything. So if with this plus time this time this time this, and after calculating the value of everything, we cannot use the division operation. That's a problem again. All right, so okay. That's hard. Okay, so let's say we're gonna append. 1 to the array. We're gonna loop through this. 1. No, that's hard to think of outside the box. To solve this, okay, let me see. Okay, so let's say we append 1. We grab this one, we times it with 2. There's gonna be 2, and then we time this one with the value previously here. It's gonna be 2 for this 6, and then we're gonna go right here. We time this value with this value, 24. So if we reverse this, oh shoot, that's bad. All right, so let's remove this. That's a bad implementation. Actually, that's not a bad implementation, but we're gonna see if we could. All right, so let's grab. Let's actually do it like that. We're gonna do a product of every element of this except the actual element that's in there. Okay, so let's start it off like that. So this element, we wanna time this to put it here. All right, so let's say if we have a counter which is gonna keep up where we are in the array. So we're gonna say for I and blah blah, and then this counter is gonna be 1. So we're gonna say in 1. That's gonna be a long algorithm in that case. So if we say the counter is 1, which is gonna be the first value, we're not gonna add that since we got 1 in the array. Or we can say there's a limit and then we say we just add 1. But we cannot. Or we can say counter is equals 1. So now if the value equals that counter, we're gonna skip it. We're gonna continue the loop. If it's not, we're gonna time it, time each value to that total. We're gonna say total. Okay, so let's actually try to implement it. If we have a counter equals 0, okay, 0. So the first value in the array is 0. So we're gonna say for I in range the length of nums. Now if I or we can do another for loop for j in range the length of nums if I equals counter, we're gonna continue. And then if it's not equal counter, that means if it's not at 0, the first value, at the end we're gonna say counter plus equals 1. Now if it's not at the counter, at the first value, we're gonna multiply it. No, we have to say for j, if j equals counter, we're gonna say continue. If it's not, wait, how to skip an iteration loop Python is continue. Okay, that's perfect. That's perfect. So we're gonna say that's j. If j equals that counter, we're gonna say continue, but we increment the counter after. Now we're gonna say nums at j val equals we're gonna say val equals 1. So if we say val equals 1, we're gonna add that. So val equals nums at j is equal to that number. Okay, so we're gonna say val equals, or we could say times equals nums at j. And then after that, counter equals 1 plus equals 1, and then we're gonna say answer the append var, and then var equals 1, and we're gonna continue to that loop. We're gonna continue to that loop. That's a high complicated answer. Hopefully it works. It doesn't. Oh, we're gonna return nothing. At the end, we're gonna return answer Hopefully that works. Wait, what? Oh, I was in the wrong line. Oh shoot. Did that just work? Oh no, I think it's gonna time limit because that was a freaking long type of array. What the hell? What the hell was that? Can they actually use that test case? That's so dumb. These people are so annoying. That long ass array. I think they purposely did that. So, what would be that answer? Okay, so that makes sense now because that's a complicated. I actually doing a O of n square algorithm. That's why they were saying to do it in O of n time. That's an O of n square. So how can we implement this? What else can we do to make this more simple? We have to think about outside the box. Let's go back to our whiteboard. Let's say we have this, and then we start right here. 4. And then we add 4 to the array. What if we have 2 array? The second array is gonna keep track of what we don't add. We're gonna say dot 4 times because we need to add all those values before getting to that. Okay. I don't remember how the flip I solved this, but we don't got time no more. We're gonna look at the solution. Actually, I think I have solved it before. I don't remember how did I solve it. Let me see the submission. I don't remember no notes. I didn't take no notes on that. That was a while ago. When was that? That was December 2024. That wasn't a while ago. I just forgot how did I solve that. It was definitely of an algorithm, but I had to actually run it twice. So we said for I in the range of n, which is gonna be the length of num. So we have those numbers. It's gonna be 4, the range of 4. Result at I at that value equals prefix, which is gonna be, I don't know why it's 1, but yeah, it's gonna be 1. And then prefix times equals number at I. So this is gonna multiply it by the number itself. And then it's gonna loop again. So 2. The second number, let me actually take this code and actually go in the whiteboard and try to find out what the hell this is saying. Alright, so let's unzoom. Let's delete this. Alright, so we're gonna say this shit right there. So the length of num is gonna be 4. And then result, wait, what? Yeah, result times 4. I don't know why exactly they did that. So the prefix is gonna be 1. Prefix is gonna be 1. So you're gonna look through this for I in the first value right here. The result at I, which is gonna be the first number, is gonna equals to that prefix, is gonna be 1. So the second value right here, and then prefix is gonna be equals to nums at I times nums at I, which is gonna equals to 1 again, because nums at I times itself times this one is gonna equals to 1. Okay, we're gonna forget that. Next iteration, ei equals to prefix, which is gonna be 1 again. And then prefix equals times equals nums at I, so it's gonna be changed to 2. Let's keep going. So the third iteration, 3 times 2. No, never mind. Result equals prefix is gonna be 2. Result equals prefix. Result I equals prefix. And then 2, and then prefix times this one equals 3 times 2, what is 6? 6, and then I think we up with their iteration. No, actually they have to go to the last value. Oh, it's the range of n. Length of num is gonna be 4. Oh, until 4. 0, 1, 2, 3, 4 times 2 times 3, sorry. How about I got 12? And then we're gonna stop right here. And then suffix equals 1. My mouse writing is different. It's kind of annoying, but yeah. So for I in the range of n minus 1, it's gonna decrease, and then it's gonna basically do the inverse. Print out the inverse. All right, so this one, result at I equals to suffix. So result at I, because that one equals to suffix, which is gonna be 1 again, because remember we're gonna keep that. And then suffix equals nums at I, which is gonna be this one times this one. It's gonna be that, and then it's gonna stay 1, right? And then you're gonna keep going again. The second one, result that I times suffix, which is gonna be 1. It's still gonna be 1 again. So right there. So this times equals I, nums at I, which is gonna be the number 2. Result at I times suffix. So this number right here is gonna multiply it by this one, 2 times 2, 4. So this is where we start. Oh shoot, I kind of mistaken right now, because we're not gonna take the last value. So that makes sense. We're gonna start at the end, because this is an inverse algorithm. So suffix equals 1. So we're gonna grab the 12 right here. 12 times suffix equals gonna be 1. So result that I times suffix, result that I times suffix equals 12. And then suffix times nums at I, which is gonna be 1. 12 times 1 equals 12 again. We're gonna keep going. Number 6. 6 equals result at I times suffix 6 times 12. No, I think I mistaken it. No. I'm actually like swallowing this right now. But let's try to look for another solution. Oh, I don't have this. Looping the input array twice. This is a nonsense. Try to watch this video. Let's watch this video together, I guess.
Output is 24, 12, 8, 6. So 24 is consisted of 2, 3, 4, right? And 12 is consisted of 1, 3, 4. And 8 is consisted of 1, 2, 4. And 6 is consisted of 1, 2, 3. So first of all, let's think about the 24. So to make 24, we need index 1 and index 2 and index 3, right? 2, 3, 4. So seems like if we iterate through from the end, I mean from this side, so we can easily create a 24 because the three numbers are next to each other without a skip, right? So first of all, we find 4 and then move next and we find 3. So we multiply 4 and 3, so that is 12, right? And then move next, so we find 2. So 12 multiply 2 is 24, right? So we can create a 24 easily if we iterate through from the end, I mean right side. Okay, next, let's think about the 12. So we need index 0. So we need 1 and index 2 and index 3, right? And in this case, seems like we can easily get index 0 from the beginning. And we can get easily index 2 and 3 from the end. Because the two numbers are next to each other without a skip, right? Okay, next, let's think about 8 and 6. For 8, we need index 0 and index 2, 3. So
Basically, that's like about the same
I guess, but
thought of
the
like.
calculation can be checked the right index. So let's see how it works. Okay, so this is the output, I mean return value. So we initialize output with 1 because 1 doesn't affect the result of multiplication. And we have left variable. So left is a total of multiplication on the left side. So first of all, multiply left number and 1 to index 0 in output. So 1 multiply 1 is 1, right? Then multiply index 0 in input array to left because at index 1, so index 0 is one of left numbers, right? So 1 multiply 1 is 1, so left is 1. So in end output is still 1, 1, 1, 1, and the left is 1, and we are now index 0. And then move next. So now we are index 1. So we do the same thing. So first of all, we multiply left to index 1 in output. So 1 multiplied by 1 is 1, right? So that means we use index 0 because left is like a total of multiplication, right? And then after that, so we find 2. So multiply 2 with 1 because as I told you, left side of index 2, right? So that's why 2 multiplied by 1 is 2. So left is now 1 multiplied 2 is 2, right? So looks good. And then next we index 2. So we repeat the same process. So first of all, multiply left to index now 2. So that's why here is 1 multiplied 2 is 2, right? So this 2 is coming from 1 multiplied 2, so left side of index 2. And then after that, we find 3, right? So multiply 3 with 2, so that is 6, right? And then move next. So first of all, we multiply left to index 3 output, so here. So that is 6, right? So 6 is coming from 1 multiply 2 multiply 3, right? So look at this. So 6 is consist of 1, 2, 3, right? So that is a 1, 2, 3. So looks good. And then after that, multiply 4 with 6. That is 24. And then move next. So we finish iteration from left to right. And as I told you, we loop twice. Like one is from left and the one is right. So that's why they are right variable and they also initialize with 1. We don't use left anymore. And then let's iterate through from end, I mean right side. So actually we do the same thing. So first of all, we are index 0, 1, 2, 3. And then, so let me change color. And then, so first of all, we are index 3. And multiply right number with index 3 in output. So 6 multiply 1 is 6, right? And then after that, we find 4. So multiply 4 with right number. So that is 4, right? And then move next. Now we find 3. So that is index 2. So first of all, multiply right number with index 2 number in output. So this 2 is coming from 1, 2, right? And this 4 is coming from right side. So 8 is consists of 1, 2, 4. 1, 2, 4. So looks good, right? So we get 8. I 3 is 4. So that is 1 index 1 in output. So 1 multiplied 12 is 12. And then let's check. 12 is, so 1 is coming from, so this one, I mean index 0. And the 12 is consist of 3 and 4, right? So for 12, we need a 1, 3, 4. So that's why we need the index 0, index 2, index 3. So looks good. And then before we move next, multiply 2 with right number 12. So that is 24. And then move next. So first of all, multiply right number with index 0 in output. Coming from 2 multiply 3 multiply. It's consisting.
Okay. So I kind of have like a high overview on how do I solve this problem, even though it's kind of like blurry. All right, so let's actually put that down. Let's put them down because this is kind of annoying. It's all about understanding the problem. So what? But that was what I just did right now. I think I'm gonna stop the live and pick it up tomorrow. That's the only way. So this is where I end. I'll pick everything up tomorrow. It was amazing to have you guys next to me trying to solve these problems. I know this like solution wasn't the best because when you run it, it runs and then it timed out. It runs for the both of the other like test cases, but there's one test case it's not gonna run on because of the time limit. Wait, what? How do I? Oh, perfect. Because of that, if I remove that test case and I run it, everything's gonna run fine because it's a double for loop right here. You see, but that third case right test case right there to run it, you need like a high level algorithm. So this is where I end for today, and then we'll pick it up tomorrow. Thank you guys. Good night.